Hello everyone, my today's discussion is about motion. We all know motion and rest are relative to each other and they are not absolute because the body has tendency to stay in states of motion or rest until the external force is not applied. Okay. First of all, at the start of my discussion, two categories of quantities are to be discussed. What are they? Scalar and vector quantity. The quantity which is associated with the number is scalar quantity and the quantity which is associated with the number as well as the direction is vector quantity. Just for example, distance is scalar and displacement is vector quantity. The body travels in one position to another position is distance. It takes some time and the number only is associated with it. Just for example, the body moves from one position to another position. In this diagram, we can see that is the initial position is O and the final position is A. Later, it changes its direction and from A, it goes to position B. Firstly, this object travels 3 meter and then it travels 4 meter. Ultimately, the initial position is O and the final position is B. Okay, in this diagram, we can say that the distance traveled by the object is 3 meter plus 4 meter, 7 meter. But here is a twist. What is that? Is the displacement. Displacement is the shortest length covered by the body from the initial position to the final position. Okay, this is actually OB. By the Pythagoras theorem, OB is root over A square plus AB square, which is actually, I am calculating here, OB is equal to root over 3 square plus 4 square, which is 5 meter. Here I have already written 5 meter. Actually, distance is 7 meter and displacement is 5 meter. Whereas we can say that displacement is associated with the number and this direction, because here in this figure we all see that the body changes its direction. That's why I can calculate the shortest length between the initial and final position. But displacement is actually vector quantity and scalar quantity is what? Scalar quantity is distance. Okay, so this is the big difference between distance and displacement. Another type of difference is there. Distance is actually can be only positive, but displacement can be 0, positive, negative. Just for example, how it can be 0 when the body travels from one position, goes to another position and then back to the same position. So there is no difference between the initial and final position. Just for example, the body travels from this position, goes here and back to this position. Okay, in this way, so there is no difference. The initial position is this and the final position is also this. So there is no difference between the initial and final position. The displacement is here 0. So another type of difference is this. Okay. Now I am talking about the SI unit. Okay, scalar quantity, vector quantity, displacement and distance. This is the this type of problem can be in your exam paper. And now I am talking about the SI unit. The SI unit for distance is meter. The SI unit for displacement is also meter. Okay, when in your exam paper the problem can be from kilometer, okay, centimeter, then you have to convert it to the meter to get the answer. Okay. Now I am shifting my discussion to the later point. Next point is speed and velocity. Speed and velocity. Okay. Actually, the ratio of distance to the time is speed. So this is a scalar quantity and the SI unit is meter per second. But the ratio of displacement to the time is velocity. So this is a vector quantity and the SI unit is also meter per second. There is no difference in the SI unit, only the quantity is different. Speed is scalar quantity and velocity is vector quantity. Okay. Here is another type of problem you can face in your exam paper, which is that the bike rider starts his journey from Delhi and goes to Chandigarh and then he backs to Delhi. Okay. The initial odometer reading was 4,200 km and the final odometer reading is 4,500 km. So, by the odometer reading, we can find the distance. Okay, 4500 minus 4200. The distance covered by the bike to go from Delhi to Chandigarh is 300 km. And the time taken by the bike rider is 3 hours. So the speed is here distance by time 300 by 3 kilometer per hour. You have to convert it kilometer to meter and 1 hour to second. 1 hour is equal to 3600 second and 1 kilometer is equal to 1000 meter. And then calculating this problem, you will get the actual speed. But now what is that? The bike rider starts from Delhi, goes to Chandigarh, again goes back to Delhi. So there is no displacement. So displacement is 0. As the displacement is 0, the velocity displacement by time, it is also 0. Okay. As same as the displacement, velocity can also be 0, positive and negative. Now I am shifting my discussion to the next point, which is acceleration. Acceleration is the rate of change in velocity, ratio of change in velocity to the time. Okay, there can be an initial velocity when the body starts its journey. There can be an initial velocity, and when it covers the journey, there can be a final velocity. So initial velocity is u, and final velocity is v. So the change in the velocity is v minus u, final minus initial, and this is divided by total time taken by the body. So v minus u, the change in velocity divided by change in time t, is acceleration. Velocity can be increased or decreased. If this is decreased, the acceleration can be negative because the formula is not greater minus lesser. Okay, the formula is not greater minus lesser. The formula is v minus u. When v is less than u, the acceleration can be negative. When v is greater than u, v minus u, v is greater than u, the acceleration is positive. Okay, when there is no change, so this is acceleration is 0. Here also I can say the acceleration is a vector quantity, and as it is a vector quantity, it can also be 0, positive, negative. Okay, the problem can come such as the initial velocity is 2 meter per second, the final velocity is 5 meter per second. We should like this put it in this formula, 5 minus 2, and the time taken is 3 seconds. So this is 3 by 3, 1 meter per second square. Yes, the SI unit for the acceleration is meter per second square. Okay. Now, what is the next point is uniform versus non-uniform. Actually, when the path is lonely, the bike rider, the body can travel equal amount of distance in equal interval of time. This is actually the uniform motion. When this is a crowded path, in the non-crowded area, the body can move fast. In the crowded area, the body can move slow. So there is a difference. So that we can say the body can move on equal amount of distance in an equal interval of time. So this is a non-uniform motion, and non-uniform motion, by uniform motion we can say uniform speed, velocity, acceleration. From non-uniform motion we can say non-uniform speed, velocity, acceleration. So all these from this motion from motion we can get divided by time the speed, velocity, acceleration ideas. Okay, now the next point is about the average. We said before that there can be initial and final velocity or initial and final speed. So the average speed is what? The average velocity is what? We have to get the total amount of initial and final velocity, initial plus final velocity or initial plus final speed, and this total number has to be divided by time by this formula. Okay, initial plus final divided by time, that by this formula we can get the average speed or average velocity. The SI unit is meter per second. Okay, I think up to this discussion we all have understood what is going on. First, motion, speed, velocity and acceleration, and scalar vector quantity, and all about the SI units and problems. Now the main part of my discussion is the graphical representation. From graphical representation we can also get the answer about speed and acceleration, velocity like this. And in your exam paper this type of problems can come, so you have to practice all these. Some of my examples, okay, some of the examples are shown here in this discussion. Please follow my words. Okay, first I am telling about distance time graph, which is uniform and non-uniform, and velocity time graph, uniform and non-uniform and constant. These 5 types of graphs is there. Okay, for the distance time graph, uniform, first of all, graph is a x-axis and y-axis. Along x-axis we have to put the time, along the y-axis we have to put the distance. Okay, now from distance time graph x-y-axis we can get the number of speed. Speed is del d by del t, means distance is divided by time. Here the speed we can get. Okay, so for the uniform speed or uniform motion we can get this type of a straight line from the corner, and when this is non-uniform motion this type of graph we can get. Okay, now the next point is velocity time graph. When this is uniform, this type of a straight line we can get for the constant. This type of straight line parallel to x-axis we can get. Now zigzag type of graphical representation we can get for the non-uniform part, and here x y axis, along x axis time is put, along y axis velocity is put here. When we divide velocity by time, means v by t, we can get what? The acceleration. Okay, by this graphical representation we can get the acceleration, and by this graphical representation we can get speed. Now I am shifting my last point in my discussion, which is the problem. Whatever problem we can face in our exam paper is that in this type of graphical representation, which is x-axis, y-axis, distance and speed. This is distance time, sorry, speed not, distance time graph. Here is this position is 0, 0. The first position is A, the final position is B, and at A position the time is 2 seconds. At B position, does dotted this line, the time is 5 seconds, and at A position the distance is 0, and at B position the distance is 3 meters. Okay, now the question is, when the body shifts its position from A to B, what is the speed? By this graphical representation, speed is actually distance by time. Now distance, what is distance? 0 to 3, the distance is 3. And time is 2 second to 5 second, to 5 minus 2 means 3 by 3, 1 meter per second. Without the SI unit written, only number is not qualified, is disqualified answer. Okay, so we all have to mark the SI unit with the number. So 1 meter per second. So in this way, this type of graphical representation we have to solve. Okay, and the next part is, this is XY axis velocity time graph. And what is the problem here? The initial position is A, the final position is B. At position A, time is 0 second and velocity is 0 meter per second, because this part is 0. The final position B, the time is 2 second and the velocity is 4 meter per second square. So to get the acceleration, V by T, velocity by time, here velocity is 4 minus 0 and time is 2 minus 0, and this is 4 by 2, 2 meter per second square. So first I have to notice the initial position, time, distance or velocity, and the final position, time, distance or velocity. Then we have to follow the formula, speed, distance by time, acceleration, velocity by time, and here we have to put the numbers. Okay, for distance, initial, final difference. For time, initial, final difference. Here is also initial, final difference and initial, final difference. From this difference, we will get the last answer. Okay, speed or acceleration. And these type of problems we can face to practice in your home. Okay, practice makes you perfect. Okay, so this is all about my discussion about motion. I think the whole discussion is going to be very much useful to you. If you have any type of question, please write in the comment section. And if you like this video, please go to Google Play Store and download Knowledgeflame app, and please subscribe YouTube Knowledgeflame channel. Thank you.